Hi, welcome to my video on place restrictions on a function so that the inverse is a function. Part 2. Let's look at the parabola f of x equals bracket x minus 2 squared. So this parabola has the vertex of x is 2, y is 0 because there's 0 on the end. And in a parabola, the x belongs to the real numbers because we use all the values of x in this equation. And the range is y is greater than or equal to 0. It goes up from 0. Notice there's a plus. So we'll take the vertex of 2, 1 and put it in the middle. Take the 3 and 4 and we'll take the 1 and the 0. Sub them into the equation, and 3 placed in here gives me a 1 squared is 1, so the 1 on the other side gives me a 1, so we put a 1 in here, you get a negative 1. When you square it, you get a 1. Place a 4 in the place of x, you get a 2 squared is 4, and you place a 0 in the place of x, you get negative 2 squared is 4. So if we have vertex is 3, 1, x is 3, y is 1, and we have vertex is 2, 0 right here, and a 3 gives me a 1 and a 4 gives me a 4, and on the other side 1 gives me a 1. When x is 1, y is 1, and when x is 0, y is 4. Notice the parabola is symmetrical. This is the parabola. Make sure it goes up through that point. Notice this is the vertex of 2, 0, so when you move 1 right or left, you get the same y value. When you move 2 right or left, you get the same y value of 4. Now, okay, let's make that, okay. Let's state the restrictions on the f of x so that the inverse is a function. Right now, it fails the horizontal line test because the horizontal line goes through 2 points. Notice these two. It goes through 0, 4 and 4, 4, so the y value is the same. So there's many horizontal lines that the inverse is not going to be, so we had to restrict it. So we're restricted at the 2, 0. So we take x is less than or equal to 2, and we take x is greater than or equal to 2. So less than or equal to 2 gives me this part of the parabola. And if you take this piece of the parabola here, then the horizontal line only goes to 1 point. If you take the part of the parabola that's on the greater than or equal to 2, you have a piece of the parabola on the right, so it passes the horizontal line test. So let's write the f of x with the restriction, number 1 restriction. So the f of x is equal to x minus 2 squared, and we're taking x to be less than or equal to 2. So we're taking this side, which is the left side. So if we find the inverse f to the negative 1, so we make the f of x a y. We change the y to an x and an x to a y. And we solve for y, we have to do the square root first, so it's plus or minus the root of x. And we solve for y, we get plus or minus the root of x plus 2. So that's the inverse. But the inverse is made up of the plus minus root x plus 2. So the inverse is made up of both parts. But we only want the part that x is less than or equal to 2. So if x is less than or equal to 2, and the y comes out to be, the y value is 0, so the y is greater than or equal to 0. Now, the domain becomes the range, and the range becomes the domain, so x is less than or equal to 2, so the y is less than or equal to 2, and the range of the f of x x is less than or equal to, I didn't put equal to 0 there. So that means the range becomes a domain greater than or equal to 0. So instead of having, since it's the left side, that means the y is less than or equal to 2, so it's the negative. So the f to the negative 1 of x, instead of being both the left and the right side, it is only the left side, and the left side is the negative. So that means if we do a table of values on that f of x, and let me do the table of values in red. So the table of values you have is this part right here. So we have the left side x's greater than or equal to 0, so that's the 0, 1, 4. And the y is less than or equal to 2, so we have 2, 1, 0. So because they're interchanged, so the 2, 0 becomes 0, 2, 1, 1 becomes 1, 1, 0, 4 becomes 0, 4. 0, 4 becomes 4, 0. And so just check these out. If you take these values and plug them in here, you will get these y values. So that means we picked, when we picked this point, we picked the 1, 1 and 0, 4. So that's that side. That's the left side. So when we do its inverse, the inverse are 0, 2. The inverse of 2, 0 is 0, sorry. The inverse of 2, 0 is 0, 2. So 0, 2 is right here. And the inverse of 1, 1 is 1, 1. And the inverse of 0, 4 is 4, 0. Right here. So the inverse is this. So this is f to the negative 1 of x. And here's my black pen. And this is the f of x. So notice we're taking the left side. And the left side is the negative. So what about if we take the other restriction? That is the f of x equals x minus 2 squared, where x is, again, the other side is the right side greater than or equal to 2. So if I solve this very same thing as here, so I work it all the way down, right down to here, and you come down, if you solve this, there it is there, same as here. So there it is. But in this one, your domain is x is greater than or equal to 2, and the y is still greater than or equal to 0. So your domain becomes your range. So y is greater than or equal to 2, and your range becomes your domain. X is greater than or equal to 0. So notice with this restriction, the y's are greater than or equal to 2. So that means the f to the negative, better be careful, f to the negative 1 of x is greater than or equal to 2 is the positive part. There it is. So if that's the positive part, let's look at the table of values in terms of its inverse. So the table of values, then it's reversing these. So 0, 2, 2, 0, 2, 0 becomes 0, 2, and 1, 1 becomes 1, 1, and 0, 4 becomes, I'm going up because we're looking at the y's greater than 2, so we pick up 4, 4. So notice 2, 0 becomes 0, 2. What I get 1? That's a 1, 1, 3. Sorry about that. And 4, 4. Let's just check it out. 0, place a 0 in here and I get a 2. Place a 1 in here and I get a 3. Place a 4 in here and I'll get a 4. Perfect. So let's graph the original. This is the right side. So I got 2, 0, 3, 1, and 4, 4. So this is the right side. X is greater than 2. And Notice x is greater than 2 and y is greater than 0. So its inverse is x is 0, y is 2. X is 1, y is 3. X is 4, y is 4. So there's his inverse. And this is f to the negative 1 of x. And the other one is the f of x. So you can see. And again, to repeat, this parabola fails the horizontal line test. So we have to pick the left side or the right side so that its inverse is a function. So there's the left side, which you can see is going down, and this is the right side, so you can see it's going up. So left is negative and right is positive. So let's have a look at another parabola. If I can turn this page over. Okay, let's look at another one, but this time the parabola is different, same shape, but it's going down. So we have a parabola here. So the vertex is x is negative 1. When x is negative 1, that becomes a 0, so y is 3. Your domain is x belongs to the reals in all parabolas. And this range, the y value starts at 3, and because it's negative, it's going down, so it's less than or equal to 3. So let's look at the table of values for its graph. The vertex is negative 1, 3. So I'll pick a negative 1, I'll pick a 0 and a 1, and I'll pick a negative 2 and a negative 3. So take a 0 and plug in here. Put a 0 in, I get 1 squared is 1. Minus 1 plus 3 is 2. So that's a 2. Put a 1 in. 1 plus 1 is 2. 2 squared is 4. Negative 4 plus 3 is negative 1. So that's negative 1. So I have a vertex of negative 1, 3. And 0 gives me a 2. That means negative 2 gives me a 2 on the left and right. And 1 gives me a negative 1. And a negative 3 gives me a negative 1. Negative 3 gives me a negative 1. So here's the parabola going downward from the vertex. So it's going down from the vertex of negative 1, 2. So this is the axis of symmetry. Because its vertex is negative 1, the axis of symmetry splits it into 2 equal pieces, symmetrical on each side. So the reflection is the x-coordinate of the vertex. So the reflection is x is less than or equal to negative 1. X is greater than or equal to negative 1. So this is the left side, and this is the right side. So let's deal with the left side. So f of x equals the negative x plus 1 squared plus 3. And we're dealing with x is less than or equal to negative 1. So change the f of x to a y. And okay, change the f of x to a y. Not get ahead of myself now. Done. The f of x is a y. Now I'm going to change the y to an x and an x to a y. So I'm solving for y, so I'll move the negative plus 3, make it a minus. Multiply negative 1 by both sides, so it makes it negative x plus 3 equals y plus 1 squared. Now I'll do the square root, so it's plus minus the square root of negative x plus 3. So y is equal to plus minus the square root of negative x plus 3, subtract 1. But this inverse, f to the negative 1 of x, that's both sides. So that's this side, which is the negative, and there's this side, which is the positive. But we only have one piece selected, so let's just check. So what we have a domain of x is less than or equal to negative 3, and we have the range is the y value starting at 3 and going down, so that's less than or equal to. So that means the domain is the range, so y is less than or equal to -1, and the domain is the range is the domain, so x is less than or equal to 3. So we think about it, we have we're picking the left side, so we're taking this one right here. So we got at 1 gives me a -3, -2 gives me a 2, and -3 gives me -1. So we're picking this side of the parabola. And the left side is the negative. So let's draw a table of values and see if we can do its inverse in the red. So the red is, so we're taking this right here and doing the inverse of it. So 3, 2, -1. 3, 2, -1 is let's see, y's become the x's become the y's, so it's -1, -2, -3. And we checked this in our equation, but we didn't. The equation is, we got both of them, so f to the -1 of x is, that's the left side, is the negative of that root. There it is. Both of them are, when I do both of them, it's doing the left and right, but I only want to deal with the x's on the left side. So its inverse is this table of values which satisfy this equation. So 3 gives me a -1, 3 gives me -1, 2 gives me -2, and a -1 gives me -1 gives me -3. So there's its inverse, going like this, and both of them are, so this is f -1 of x, and this is the f of x. And as we can see, or should see, check to see if this is right. Take the 3 and put in here. We get 3 here gives me a 0, which gives me -1. Put a 2 in here and I get a 1. And so, in this equation, I got both of them here. So if I take 2 and put in this equation, I get a 1. -1, -1 is -2. Put a -1 here. Negative of a -1 is 1. 1 plus 1 is 3. Square root of 1 plus 3 is 4. Square root of 4 is 2. So it gives me -2, -1, -3. Perfect. So everything works. And we also have to look at, this is the left side, which is the negative. Now I'm going to do the right side. So we write it down again. There we go. So this time I'm taking x is greater than or equal to -1. And the what I did workings here, so this is the same workings here. I don't have to do that again. So I get f to the -1 of x is plus or minus square root -x plus 3 minus 1. And let's just check. Let's see. Here we go, x and y. Now I'm going to use the red. So my f of x is x is greater than or equal to -1, and the y value starts at 3, and because it's negative, the y's go down, which is the same as here. Now I'm going to mark I didn't do it up here, but let's mark it in red. The domain is the range. The range is your domain. So if x is greater than or equal to -1, y is greater than or equal to -1 here. If y is less than or equal to 3, x is less than or equal to 3. So the y values are the upper part of this. So that's going to be the 3, 2, -1. 3, 2, -1 becomes -1, 0, 1. -1, 0, 1. And let's just check. That means that y values are greater than -1. So that means the f to the -1 of x is greater than -1 is the plus. So that's the positive of the root of -x plus 3 minus 1. Again, the left side is the negative. X is less than or equal to, so it's the negative. And this is the right side, so it's the positive. And so if you check the table of values, put a 3 in here, you get a 0, which is -1. Put a 2 here, you get -2 plus 3 is 1, square root of 1 is 1. You get a 0. And if you check the -1, you get a 1. And so I'm on a graph, I'm dealing with this part of the parabola. So that's that one, and that one, and that. So you can see there's the points right here, here, and here. So this is this side of the parabola, which is going to the right. So notice x is going to the right and y is going down, which makes sense right here. And so its inverse is 3 gives me -1. 3 gives me x is 3, y is -1. X is 2, y is 0. X is -1 and y is 1. And so we can see that the graph is doing this because the x values start at -3 and go left, and the y values start at -1 and go up. So this is f to the -1 of x, and this is the f of x. So you do one in black is the original with the restriction, and there's his inverse right there. So that's a complete review of using the horizontal line test. And again, notice when you do the inverse of this part, there it is, and we get this, the black part here passes the horizontal line test. So therefore, when you do its inverse, it is a function because it passes the vertical line test. And the same here. This part, because we restricted it, passes the horizontal line test. So this is its inverse, and it's a function because the horizontal line becomes a vertical line. So this vertical line only passes through one point. So that's a review of doing the horizontal line test on a parabola. You have to restrict to the left side or the right side. And if you like my video, click on the like button. Click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my video, and the content. That's the content on my YouTube channel called Math Fully Explained, which is just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.